At 3:17 in the morning, radar operators aboard a United States aircraft carrier in the Strait of Hormuz watched 200 fast-moving contacts explode across their screens at once. The formation looked chaotic at first, then the pattern became obvious. This was not a reconnaissance sweep, it was a saturation strike, a coordinated Iranian drone swarm moving low over the water, designed to overwhelm the carrier's defense systems before commanders could react. Because modern naval warfare is no longer about sinking ships with one missile, it is about forcing a billion-dollar defense network to process too many threats at the same time. But the problem inside the carrier group was worse than anyone expected. The drones were flying beneath standard radar angles, splitting into multiple attack vectors, using commercial navigation signals and cheap thermal masking systems copied from conflicts in Ukraine and the Red Sea. So within less than 2 minutes, the most expensive naval platform on Earth was suddenly fighting the same kind of asymmetric swarm tactics used by insurgents with motorcycles and laptops. And then the carrier lost visual confirmation on nearly half the incoming contacts. That was the moment commanders realized this was not a demonstration. It was a kill scenario. But the radar did not see what was coming next. Less than 100 miles away, an AC-130 gunship was already turning toward the Gulf. The official version of events would later describe the situation as a routine regional escalation. That phrase hid the panic spreading through the command network inside Fifth Fleet operations, because 200 drones approaching a carrier strike group in confined waters creates a nightmare equation for naval planners. Every interceptor missile fired from a destroyer costs millions of dollars. Every attacking drone might cost less than a pickup truck. But the real danger was mathematical. Even advanced Aegis systems can begin struggling when multiple low-altitude targets appear simultaneously across different approach corridors. So the entire American strategy in the Gulf suddenly depended on one question. How many targets could the carrier group destroy before something slipped through? Satellite imagery from previous Iranian naval exercises had already shown large drone dispersal patterns near Bandar Abbas. Pentagon analysts spent years warning that Iran's real strategy was never direct naval confrontation. It was swarm attrition. Fast boats, drones, mines, electronic warfare, and coastal missile batteries all attacking together in confined water where large ships have limited maneuverability. Because the Strait of Hormuz is one of the most strategically vulnerable waterways on Earth, nearly 1/5 of global oil traffic passes through it. But the geography traps warships inside narrow operating lanes surrounded by hostile coastlines. So even the world's strongest navy enters the region with constraints. Iran understood that. And they designed their drone doctrine around it. The first wave approached from the northeast. Small delta-wing drones flying barely above the waterline. The second wave came from higher altitude angles designed to trigger defensive radar prioritization, but hidden inside the formation were electronic warfare drones broadcasting false signatures intended to confuse tracking systems. So American operators suddenly faced a battlefield where real targets and fake targets appeared together. Then the destroyers opened fire. Missiles erupted into the night sky as standard interceptors streaked across the Gulf. Several drones exploded instantly. Others vanished from radar only to reappear seconds later from new vectors. Because the swarm was constantly changing shape. But every interceptor launched created another problem. Magazine depth. Naval commanders never discuss it publicly, but missile inventories disappear frighteningly fast during saturation combat. A destroyer can burn through advanced interceptors in minutes under heavy attack conditions. So while explosions filled the sky above the Gulf, officers inside the carrier group were already calculating how long they could sustain the defense. And the answer was not comforting. The Pentagon had spent years preparing for ballistic missiles and hypersonic threats from China and Russia. But cheap drone warfare changed the economics of conflict completely. In Ukraine, commercial drones destroyed tanks worth millions. In the Red Sea, Houthi drones forced rerouting operations that disrupted global shipping markets. Because modern warfare no longer rewards the side with the most expensive equipment. It rewards the side capable of overwhelming systems faster than they can respond. But inside the Gulf that night, the United States suddenly faced the possibility that a carrier strike group could be trapped in exactly that scenario. Then one drone broke through the outer defensive screen. Video later leaked online showing a bright flash near the water several miles from the carrier formation. Analysts argued for weeks about what actually exploded. Some claimed it was debris from an interceptor. Others believed the drone detonated prematurely. But intelligence chatter inside regional defense circles suggested something far more dangerous. At least one drone may have reached engagement range before being destroyed. So even though the carrier survived untouched, the psychological effect inside naval command structures was immediate. The swarm had gotten closer than expected. And that changed everything. Because carrier groups are designed around deterrence. Their real power comes from perception. The belief that approaching them is suicide. But the drone age is eroding that perception piece by piece. Militias with commercial technology can now threaten strategic naval assets that once dominated entire oceans uncontested. So American commanders understood that if footage of a successful swarm penetration ever reached global media, every hostile actor on Earth would begin copying the tactic immediately. That was when the AC-130 entered the battle space. Unlike stealth fighters built for high-altitude penetration, the AC-130 was designed for persistent battlefield destruction. Side-firing cannons. Thermal targeting systems. Infrared tracking. Massive airborne firepower orbiting above a combat zone like a flying artillery platform. Because drone swarms create one specific problem for traditional missile defenses. Cost imbalance. But guns firing explosive ammunition solve that problem differently. They do not chase precision kills one missile at a time. They saturate airspace with controlled devastation. The gunship rolled into firing position above the Gulf. And then the ocean lit up. Tracers ripped across the darkness in long streams of fire as the AC-130 began targeting clusters instead of individual drones. Explosions erupted across the swarm formation. Burning debris slammed into the water. Several drones collided midair while attempting evasive maneuvers. Because the swarm relied on tight coordination algorithms to maintain attack geometry. But sustained airborne cannon fire shattered the formation faster than Iranian planners expected. So within less than 90 seconds, the entire attack pattern collapsed into chaos. Operators aboard the carrier reportedly watched dozens of radar signatures disappear almost simultaneously. Because carrier groups are designed around deterrence. Their real power comes from perception. The belief that approaching them is suicide. But the drone age is eroding that perception piece by piece. Militias with commercial technology can now threaten strategic naval assets that once dominated entire oceans uncontested. So American commanders understood that if footage of a successful swarm penetration ever reached global media, every hostile actor on Earth would begin copying the tactic immediately. That was when the AC-130 entered the battle space. Unlike stealth fighters built for high-altitude penetration, the AC-130 was designed for persistent battlefield destruction. Side-firing cannons. Thermal targeting systems. Infrared tracking. Massive airborne firepower orbiting above a combat zone like a flying artillery platform. Because drone swarms create one specific problem for traditional missile defenses. Cost imbalance. But guns firing explosive ammunition solve that problem differently. They do not chase precision kills one missile at a time. They saturate airspace with controlled devastation. The gunship rolled into firing position above the Gulf. And then the ocean lit up. Tracers ripped across the darkness in long streams of fire as the AC-130 began targeting clusters instead of individual drones. Explosions erupted across the swarm formation. Burning debris slammed into the water. Several drones collided midair while attempting evasive maneuvers. Because the swarm relied on tight coordination algorithms to maintain attack geometry. But sustained airborne cannon fire shattered the formation faster than Iranian planners expected. So within less than 90 seconds, the entire attack pattern collapsed into chaos. Operators aboard the carrier reportedly watched dozens of radar signatures disappear almost simultaneously. Their objective was never necessarily to sink a carrier outright. The real goal was demonstrating vulnerability. Because forcing the United States to spend millions defending against cheap swarm attacks creates long-term strategic fatigue. But the rapid destruction of the drone formation by the AC-130 complicated that narrative significantly. So instead of broadcasting American weakness, the battle exposed something else entirely. Modern warfare was evolving faster than anyone admitted publicly. Inside Washington, defense analysts began quietly revisiting assumptions about carrier warfare itself. Because aircraft carriers dominate through concentration of force. But drone swarms thrive by dispersing cheap attrition across wide areas. So the entire logic of naval supremacy suddenly faced uncomfortable questions. How many drones would future attacks involve? Could swarms coordinate underwater and airborne strikes simultaneously? What happens when artificial intelligence removes human reaction delays entirely? Nobody inside the Pentagon wanted to answer those questions publicly, because the answers threatened decades of military doctrine. And somewhere inside Iran's military command structure, officers were likely studying every second of the engagement themselves. Which drone survived longest? Which approach vectors created confusion? Which defensive systems reacted fastest? Because swarm warfare is iterative. Every failed attack becomes data for the next one. But American commanders were learning too. Faster airborne gun platforms. Layered signal disruption. Autonomous defensive targeting. The battle in the Gulf was not an isolated confrontation. It was a prototype for the future of naval combat. And future conflicts may involve far larger swarms. The terrifying part is that this kind of warfare lowers the barrier to entry dramatically. Nations no longer need massive air forces or billion-dollar fleets to threaten strategic targets. They need manufacturing capacity, software coordination, and enough expendable systems to saturate defenses. Because quantity itself becomes a weapon. But that changes global power dynamics completely. Smaller regional actors suddenly gain leverage against technologically superior militaries, so the Gulf engagement sent shockwaves far beyond the Middle East. NATO planners reportedly intensified internal discussions around naval ammunition stockpiles after similar drone incidents in the Red Sea. Because modern missile defense systems were never designed for endless swarm attrition. But defense manufacturers cannot rapidly replace advanced interceptors during sustained conflict. So future wars may depend less on technology superiority and more on industrial endurance. That reality deeply worried Western planners. And it explains why military officials rarely discuss ammunition depletion publicly. The AC-130 engagement temporarily solved the immediate crisis. But it also exposed another dangerous truth. Gunship-based swarm defense works best under specific conditions. Clear targeting environments. Air superiority. Manageable drone density. But what happens when swarms become larger, faster, stealthier, or autonomous? What happens when attacks occur simultaneously across multiple naval groups? What happens when decoy drones intentionally drain defensive fire before the real strike arrives? Those scenarios are already being modeled inside classified simulations. And the outcomes are reportedly grim. Because the next generation of drone warfare will not rely only on explosives. Future swarms may carry electronic warfare payloads, surveillance packages, cyber intrusion systems, or even autonomous targeting coordination powered by machine learning. So defeating one swarm today does not guarantee victory tomorrow. It simply buys time before the next evolution arrives. And somewhere in the darkness above the Gulf, military planners on both sides understood that the real battle had only just begun. The carrier survived. The drones burned. The AC-130 disappeared back into the night sky. But the strategic message lingered long after the smoke cleared. The age of overwhelming military dominance is ending. And the nations that adapt fastest to swarm warfare may control the future of global power itself.